In this clip, I'm going to look at explaining averages. So, what is an average? So, an average is a central calculated value from a set of numbers. Now, if that doesn't mean a lot to you, that's fine, because it's not overly important. You don't necessarily need to know what an average is, more how to calculate it. So how do we calculate an average? We calculate an average by adding up all the numbers and dividing by how many of the numbers there are. So, for example, if I have a set of numbers, I've got 1, 8, 5, 4, and 7. And if I add these up, 1 plus 8 is 9, plus 5 is 14, plus 4 is 18, plus 7 is 25. So 1 plus 8 plus 5 plus 4 plus 7 equals 25. So that's my total, and I want to divide by how many numbers there are. There's 1, 2, 3, 4, 5 numbers. So 25 divided by 5 equals 5. So the average of this set of numbers is 5. What I found is a set of examples from passages. That's how you calculate it. So let's see it in practice. So in this question, it says, Ponderosa pine trees produce resin following damage to their bark. In an investigation, 3 individual pine trees were chosen from an area with different population densities. Each tree was damaged by having a hole bored through its bark. Measurements of resin production from each hole followed this damage as shown in the table. And the question we're looking at is here, and it says calculate the average resin flow per day at a population density of 2 trees per hectare after the first day. So, as we go through the question again, what's the important information? Well, we're calculating an average per day and a density of 2 trees. So, the only information we need in this table is from here. We're only looking at 2 trees, we're not looking at 10 trees or 50 trees. And it says per hectare after the first day. So, we've got 3 columns. We've got a volume of resin produced in the first day, we've got the duration resin flow, and we've got total volume of resin produced. So we're looking for the average resin flow per day. So we've got the total volume of resin produced, which is 29.3. So if we take that and we want to, it's after the first day, so we want to take off the first day amount. So the volume of resin produced in the first day is 8.3. So if we take away 29, if we take 29.3 and we take away 8.3, we get 21 centimeters cubed, and that's our resin. And there's 7 days. However, we're not taking into account the first day, so we're dividing this number by 6. So if you take 21 and you divide it by 6, what do we get? If we take 21 divided by 6, we get 3.5. So average resin produced, we've taken the number, we've not had to add it up because it's already been added up for us. We've just had to take it away and to give us the 6 days, and we divide it by the number of days, which is 7 minus the first day, which is therefore 6, and giving us an answer of 3.5. Now, in the second example here, we've got the graph showing the body mass of a human male from birth until 22 years of age. And it says calculate the yearly increase in body mass between ages 6 and 14. So important information, we're looking for an average, and between ages 6 and 14. So if we look in the graph and we find age 6 is here and age 14 is here. So at 6, we've got this here. If you go across, body mass is 30 kilos. So at 6, body mass equals 30 kilos. At 14, body mass equals this point here, which is 50 kilos. So the increase is going to be the difference between the two. So difference is 50 kilos minus 30 kilos equals 20 kilos. But that's over this 8-year period. And the difference between 6 and 8 is 14. So we're dividing it by 8 years. And 20 divided by 8 gives you 2.5 kilos. On average. And that's how you do calculating an average.